Hi, my name's Nick Lobo-Brennan. I'm going to be doing together with Ciaran and Theo a little discussion together around the idea of lifespan. And just to talk maybe a little bit of that after we've introduced ourselves. So Ciaran, do you maybe want to say a little bit about who you are, and then I'll say who Theo and I are.
You want to go through the APPARATA?
No. Let's do it on the first slide. It's fine.
Okay. So I'm Ciaran Malik. I'm a structural engineer, and I currently teach at some of the architecture schools, including the Architecture Association. And this kind of comes out of some work that I've been thinking about in terms of like how do we design in the climate emergency, and so that's where we've reached this topic.
So fine. Okay. So look. So I'm glad there's a small group here. We weren't sure if anyone being here or not, but effectively what we're trying to do, Theo, Astrid and I, who run a firm called APPARATA, we are looking to change and adapt how we work every day, but also how we teach in relation to issues around energy. And we recognize that as very much a series of external things that come within the discipline, be it regulatory, be it engineering consultation. But we're interested in the idea that what ideas can emanate from the discipline of the discipline of architecture itself, from either historic figures or historic ways of building and thinking, and how as a discipline can we help form what an emerging architecture might be like. And the reason to do that is, and you'll see later, is that we've been told by various organizations that Ciaran will expand on that we have between 10 and 20 years to radically change how we use energy, which means in turn radically change how we might think about buildings. And we think it's good if that doesn't become just a technical issue, but it's also a cultural issue, a culture of habits, but also a culture of how things are expressed and look like and feel like. And so within that whole topic of energy responsibility, sustainability, whatever you want to call it, we wanted to sort of break down that issue into smaller issues that relate to architectural thinking as we've known it. So lifespan for us is a kind of fundamental architectural idea reflected in whether it's the work of Cedric Price or in the work of in the studies of Rainer Banham, or the work of Architecture Research Unit, whereby the consideration of the material, the weight of the material, the adaptability of the material is related to how long it lasts. So what we'd like to do is a kind of series of discussions around architectural ideas, fundamental architectural ideas, which we discuss with people from other disciplines outside. So be it structural engineers, be it environmental engineers, and just as a way to try and link up some sort of fundamental architectural thoughts to emerging issues. And that's probably enough of a framing, I think. Then say a little bit about APPARATA. APPARATA is myself, Nick Lobo-Brennan, Theo, and there's Astrid, who can't be here. We run a practice where we're focused on trying to make practical architecture, as an architecture that's built, a critical practice, which means that we don't want to see a distinction between sort of architecture of the academy, theoretical architecture, and practical real building. We want to see it as one complete approach. And we also try to, we sort of see that in architecture you have to choose a little bit between, are you dealing with the autonomous language discipline, or are you dealing with more political participatory techniques? And they're usually exclusive of each other. And so what we try to do is, and we think that's the core of architecture, is where those two things come together. So now part of that process, we look at materials in terms of their embodied labor, we look at it in terms of their cultural expression, but we want to make sure that part of that is its embodied energy. Theo, do you want to say something? I probably spoke for too long, but just to give a bit of framing.
No. I think the sort of key, perhaps, part of the research so far is that in relationship to technology, I guess, if I could say, energy is in the 20th and 21st century something that articulates itself in building through technology. It's been for much longer articulated as loads and forces, but maybe it's also, the research is also a little bit about looking back at promises from the past and seeing if these promises could be delivered both at an architectural and social level. So I'd say that definitely the social aspect is equally important as the technological one.
And so effectively in this, we effectively want to sort of workshop some ideas, and how we want to structure it is, one, to have a look at the bigger story, which Ciaran will talk about. But then we want to structure it around 4 stories that we have, which are 4 different projects that we've been doing over the last 4 or 5 years. And each one touches on this idea of lifespan, related, and each one is like a real kind of trying to make a building happen in London, with all the compromises, with all the problems, with all the issues of historic fabric. And talk a little bit about each one of those stories, and then Ciaran kind of responds in a way with what he thinks the issues are. But we want to get through that quite quickly, then hopefully start a discussion with the other people in the room. Yeah. We begin to workshop a little bit what connections can we make between the discipline of architecture and these seemingly external influences, which we view as fundamental and integral. All right, so fine. Do you want to carry on?
So it's okay. So essentially, so we've been working on this kind of in a very similar kind of area, and for myself, this has kind of been a process of exploration and trying to understand it. And because I think this is so, I think the climate emergency is so critical, I kind of want, whenever I understand something, I want to make sure, and as a teacher, I want to make sure that everyone else understands it. So I kind of, the way that I've been showing what I've been finding is I've been trying to draw these diagrams or these slides or like these kind of points that people can refer to when they're trying to think about these ideas. So trying to understand this and then trying to simplify that. So that's kind of the work I've been doing, and that's kind of where Nick and I have overlapped. But then there's been other work looking at just how do you calculate embodied carbon and the green recovery, and running training courses on that myself. And then the wider kind of context that, well, this is actually, sorry, Nick, this is you.
Yeah, so we wanted to say something about, we wanted to make this thing, it's a bit awkward and thing to do, but we wanted to mix up these kind of, typically when we attend talks about sustainability, the topics use the words climate or sustainability and kind of all these things. And they're very much kind of facts and figures based. And we thought, is it possible to set side by side these facts and figures that we need to know, and set them alongside some architectural history, because we're kind of moving through a historical moment. So on the screen now, you see 3 books just from our collection in the office. These are from about 1900s to the first couple of decades of the 20th century. And they sort of mark a move into full modernity, and all the issues that came with that, about responding to a new way of building, a new kind of industry. And architects are trying to kind of theorize and keep up and try and respond to it. And then if we go to the next slide, these books are, they would never be called postmodern exactly, these books, but they sort of represent a kind of selection of different ways of thinking as a movement out of modernism, shall we say. And they represent a series of different approaches that we'd like to touch on at the end, which are to do with, well, can building be more basic, like Hans van der Laan? Can it last forever? Or could it be almost nothing and disappear through machines like Rainer Banham? Or could architecture be much more selective of when it's permanent and not permanent, like in Architecture Without Architects? And Bardi offers various views on this. And Mumford tells us about, actually, when we're doing technical things, we actually have to be very careful of the culture that comes with that. So we see these books and others as some useful routes to try and grow some very sort of sensitive, specific architectural ideas that resolve carbon issues, but even go into the realm of actually regenerating the environment.
Could I just say that maybe, as you said, there are many, many, many others. I mean, the library in the office is huge, as I imagine everybody else is. And this is more of a slide as a kind of playlist of what's on the desk right now at a given time and at a given moment for a particular piece of work and research. So it's not to be taken literally that this is a discussion about these books, I suppose.
Yeah, but it's the ideas within those, which basically we'd like to test some of those ideas in discussion with Ciaran and others. We can bring them up at the end, and hopefully other people have their own, and we can sort of play through what they might mean and how they might be real or not. It'd
be nice if people ask questions through books. I think that'd be nice.
That's an interesting way of putting it.
Okay.
So one of the things that I was trying, as in, like in this process of trying to break it down, to break down this principle into something that's kind of understandable and tangible and usable, especially in teaching, was this diagram here, which is kind of looking at the different levels or different building life strategies that we can start to think about, and they kind of fit into kind of three main groups, and the idea that you kind of, that although it's not going to be ideal, you've got the idea that you can be low intervention, you can not build, and then there's another option is to use what's already there. So again, it's not another way of thinking about not building. Then there's the idea of using what's already there. So a building that's already, its life has already begun, and do you repair it, or do you just reuse the existing, like take elements from elsewhere? And then you kind of have a much more kind of long-term approach to it. And it's this idea that you design something that can then be changed in arrangement and changed again. Or do you design it, the kind of a main part of it that's firm, and then that main part of it can then be adjusted and then can be adjusted. So this is kind of the first ways that I was trying to break this down, but this comes from, so this would be an option that you might consider for a project on its whole. But then for each project, this is the carbon assessment stages. So these are kind of meant to represent all the stages involved in the design process or in the building process. And this is the method that we should all be using now to calculate our the embodied carbon or the whole life carbon of our designs. And the idea that you have a product stage that you then takes through to a construction, that the building in use at the end of its life, and then ideally that there are other ways that building may have benefits that may help your design. So this is then the life of an individual building. And this is a very linear way of thinking about this process, but there's also the idea that you could actually, that we should be thinking more cyclical, more as a cycle of the building. And that when we kind of remove that material, it goes to the construction site, it is built, it exists as a life, and it goes round, and that's the cycle. And that whenever we are doing one of these actions, there can be a risk of wasting material. So during the excavation, we could waste material. During the construction, there could be construction waste. And when we change the space, there's also an idea of waste. And so we should actually be trying to make this cycle much smaller and reuse as much of it as possible. And this idea, or the change, came from this IPCC report that we will refer to, which was basically warning of the limit that we need to hit 1.5 degrees centigrade change in temperature. And this kind of means that this kind of has added an urgency to this whole entire process. And in some ways, that if buildings have been evolving along different branches, that actually this could indicate a point where actually there's a complete branch that we need to remove from that evolution, because it won't allow us to curb global emissions. The idea is that we are emitting emissions, and that emission rate has been going up, and that we need to take as much action as we can in order to reduce that to zero, or to even lower it to a negative value. And this was part of a work that I was doing with Manuel van der Warp at RCA, where we were looking at automation as a way of instigating that change. So we were looking at reducing the transport, using satellites. And so there are already satellites doing assessments of buildings, using automated construction methods in order to reduce the waste of material. And then also to works coordinated with the energy availability. So building at times when possibly there is energy that's not being used on the grid would be another way to do this. And there is a route map or a roadmap to this, and Letty has developed this, and the idea that we're at 2020 now, and the idea of getting to 2030 and getting to zero carbon designs, that process that we should be taking to get there. And one thing that comes up that I think some people aren't aware of or don't necessarily always consider is the fact that it's been shown that 80% of the buildings that we're going to be using in 2050, when we're meant to hit this zero carbon point, have already been built. So that although we can start to think about this in terms of new buildings, but we really, in the teaching and in our work, we need to be thinking about that 80% that already exists, that we're going to have to start adapting and changing. So we're going to be intervening in the middle of the building's life. And this image comes from one of Nick's projects, and to me, I think this was a really interesting part of seeing Nick's work, and this is kind of this is like one of the points that we started to like work together, is that this is from a refurbishment, from a reuse building. So they're reusing the existing building. So you've got the existing masonry here. You've got these like radiators, which I suspect you've got iron pipes. So you have this building that has already had a lifetime of say 50 to 100 years, and you're trying to reuse that space. And so one option would be that if you had these partitions, that you might try to move those, you might try to undo those pipes and change them and move them along. But what I think was really nice about this and seeing in their work was that they had actually chosen to just completely go around it, that they acknowledged that their partition would not have the same life as the rest of the building. And so they made this active choice to do that, which I think is really interesting. And then the other part was that they chose the materials for this frame and the assembly of this frame in a way that it could be moved. So we would have, it itself would have a reuse, or it could be adjusted within the space, and that it could be disassembled and hopefully the materials recycled and reused in another way. So it's what I really liked about Nick's work and Apparatus' work as a whole.
Sorry, just to be correct. So we're going to show 4 little stories from different projects. 3 of them are reuses, and 1 is a new build that we'll end on. I just want to highlight something that Ciaran said a second ago. He was highlighting the IPPC report. Was it IPCC? I always forget.
IPCC, I think.
IPCC. But just to say that's really, really important, because there's very much a before and after that report. The reason why Extinction Rebellion and all these other things seem to suddenly become much more present again is very much to do with that report. So we could say that there's human knowledge about what's going on with our environment before that report and after that report, which is why things designed before that report are going to be different from what's designed afterwards. So anyway, so just to say something, we also wanted to sort of get this conversation going, hopefully with others. So Ciaran said something about our work, but I can say this is one of Ciaran's drawings, and we were completely sort of intrigued by it because, of course, this is not as an architect how you think about material. So it's quite challenging in a sense, where material doesn't just have, you know, a kind of perceived temperature or a construction potential. It actually has a kind of number attached to it, and that number is a kind of thing that you can spend and save, and we're supposed to save as much as possible and balance it out. So it just gives a sort of very strange and challenging reframing of how you might think about materials.
Just say also, yes, it is, but it also is something that perhaps in architectural thinking you also don't disregard. It's in the back of your mind.
Yeah, of course it is.
Thinking 100%, and I think it is also separating perhaps the performative side of an understanding of what a material is to maybe its representational potential or its physical appearance. And I think architecturally you consider it, but it was interesting to see how Ciaran had actually tried to capture the material visually beyond obviously the quantifiable side of the material, the performance. And I think that's always the tension we have found, I think, in practice, where the various disciplines meet and the quantifiable meets the possibly unquantifiable side of architecture. And that's where the interest and the potential of this relationship.
No, exactly. It's the bigger mind, but to foreground it. There's also intrigues much that we're working in a building now that is concrete. It was designed before 2018. It started off in feasibility as CLT, but for various reasons of which we can even discuss, it ends up as a concrete building. But the concrete building we've been looking at, according to using the latest calculators, has the same CO2 emission as a traditional brick building or a contemporary brick building, which is kind of an intriguing thought to have, but maybe we can drill down into that later.
Especially if you put it in the context of lifespan.
Exactly.
That's an interesting.
So if you go to the next slide, so this is a project which I'll try and speed up because I'm rambling a bit, but so this is a project that we've done in Dagenham in the Becontree estate. On the left is a before photo, on the right an after photo. And we thought it was a good one to start off with, where we were asked to take a disused, effectively a farmhouse that had been adapted in the late 1800s into a villa. So it's a solid brick wall. And the building had become unusable because the inside was, you can't really sense it here, but the building was completely damp. It got too cold. It was bad for people's breathing. And we were asked to transform this into an artist residence and a kind of community centre, which is on the right. So we had the problem of, so what do we do with this building? The council had suggested injecting chemicals into the wall at a low level to make a new kind of barrier, and it cost about £30,000. That would have meant the project would have died. We also, because that technology fails every five years, it doesn't actually solve the problem. It just kind of maintains the problem, and it's a very common building approach in the UK, which is sort of symbolic of some of the issues we're going to have if we're going to address adapting existing buildings. But what we decided to do is think carefully about why the building was damp inside, and the reason being is that it had been encased in cement in the 1970s as a way to prolong the life of the building, as was common then. The issue is that cement actually stops the building working as a natural breathing system. It trapped the water in. And we couldn't really afford to take the cement off from the outside, but also we couldn't risk taking it off the outside because it risked bringing it off might damage the face of the bricks, meaning that the bricks become more absorbent and exacerbating the problem. So we decided instead to make the building breathe inwards. So we removed all linings from the inside, and we only covered up we only covered up bricks by using a slurry, a breathable natural slurry. So the building dried out pretty quickly, became considerably warmer and easier to manage. And we turned it into sort of a kind of natural building system with a kind of late 20th century skin that was causing all the problems. That issue is also been related to how do we prolong the life of our buildings. So at the moment, I'm sure you would have heard that there are grants that have gone out to insert foam which you spray into cavity walls. This was not a cavity wall. But that, in hundreds of thousands of examples, has resulted in buildings actually becoming damaged, by becoming moldy, by becoming damp, because of the way it's been installed. Has actually damaged the building. In some extreme cases, people actually have to move out the building. And now there's a sort of sub-industry of just extracting all of those sprayed insulation. And of course, what happens, that those buildings don't get reinstate because there's no money left to do it. And the reason to tell that particular story is that if we're trying to adapt existing stock, there are some problems within the British building industry that we have to think about. Can we do what needs to be done, and what other ways can we possibly do it? And that's the first story. Should we move on?
Yeah.
This kind of came to a point that we were talking about. Is that in building design, like we've all heard the terms and we know the terms. You have this idea of, you have the embodied carbon, the carbon emissions that are associated with kind of making the material. Like, for example, if it was a brick building, it would be like the amount of carbon that was released in order to have those. Then you have the operational carbon, which is the carbon that's associated with the operation of that building. So that could be from power, it could be from the water, and that can be from the kind of heating of that building. And so again, it's the carbon emissions of that in your building. And so it's often, in some ways, it'd be easier to examine, to think about your building in terms of one of these. So for example, if we imagine that this line on this edge represents really low operational carbon, you might imagine that it would make sense to have a really thick walls and a thick structure in order to achieve that. So you go for a very dense and heavy building in order to reduce your operational carbon, but at the same time you end up raising your embodied carbon. And then the other end of this might be that you might start trying to aim to reduce your embodied carbon. So you might try to build something as light as possible, which allows as much natural light into your spaces. Where's my mouse? There it is. So you might have like a lighthouse, like a greenhouse or something like that. But at the same time, that is so in terms of embodied carbon, in terms of the material that you've actually built it out of, there's very little to it. But the operation of that, so this is just going to lose heat very easily. It's going to be too sunny, so you're going to have to use blinds, and you have to use synthetic lights on the inside. So actually, you increase your operational carbon. And similar to like Nick's story, is that the idea that when we plan our interventions to buildings, we need to make sure that they're balancing both of these parts in order to get to what should be zero carbon building design.
Well, can I just say something here, that when I first saw Ciaran's sketch on this, what I thought was interesting here, which I hadn't thought before, and maybe subject for conversation at the end, is that it made me realize that the embodied carbon is potentially, because I'm immediately kind of thinking of heavy buildings and masonry buildings in most cases, and I'm thinking, okay, so this is a structure that is actually embodying the changes of conditions of its direct environment, be it the inside or the outside conditions. Whereas in the other case, it struck me that it is a more closed idea, where there is a system at play that is trying to create conditions inside, regardless of what is happening outside. And I just wanted to throw that for thought later.
Yeah. Cool.
So the second story, this is Old Manor Park Library, which is an old Carnegie Passmore library in Newham that had stopped being used for about, I think, 10 years. And the reason being is because the council felt they couldn't maintain it. They couldn't identify where the leaks are. They couldn't identify where electrics might be. They had pipes, plastic pipes hanging from the ceiling. And the building had become a kind of collage of very short-term maintenance solutions, which didn't have any knowledge of previous maintenance solutions. One, because there wasn't an ongoing logbook or a kind of drawing set, but it became a victim of kind of maintenance fail, right? So this project, we were asked to help turn it into a kind of public hall again at the front, and a series of private studios at the back that would be involved in delivering the public hall at the front. And to do that, to do the project, we just stripped the project just to reveal all the problems and said, look, we're going to make good in certain parts we're not. But the main point is that you will see leaks and things appear, but at least we now know where they are, and we can manage the longer life of the building more clearly. and we inserted a series of ash and glass partitions, which I won't go too much into now, but other than say that we wanted to make a kind of hierarchy between new and historic, and make a kind of cultural play between clashes between new things and old things, while making it very clear what the hierarchy is. Should we move on?
Yeah. Mm-hmm. So this was something. So this is a somewhat kind of unthought about, well, like thought in process, and it's kind of thinking about everything in terms of our buildings. So one of the first things that in terms of our lifespan, is that you got your own lifespan. So if we said that we're expecting like an 80-year life or something like that, you have a lifespan for yourself of 80 years. That's probably, like, I imagine with technology, that's going to be okay. And then if you start to think about what happens at the start of, imagine this line represents the start of a project, but you kind of end up with this 2-year, so for the design phase, you might end up with 2 years. And then after that, you might have a construction, which might be 2 years. And then what's really interesting when you start to overlap some of these timelines is that, for example, the liability that comes with that design is something like 7 years. So you've got a period for the liability of that project. How responsible is the design team and everyone involved for that? You have other problems, like, for example, you've got policy at the start of that design period might change in a 4 to 8 year period for policy. You've got then also the ownership of that property, and so you might have a project that completes and that it's only owned for about 10 years. So ownership. This is trying to get bigger and bigger. And then you've got, for example, once that building is completed, that it's gonna, at some point, it'll be repaired or refurbished. And so you'd expect that to have something like a 30 refurbishment, ownership should be like 10 years. Refurbishment would be the first kind of refurbishment, might be your 30-year period. And so you can see some of these responsibilities are already coming out, that you're going to be refurbishing something that the design team may not be responsible for anymore. Or if they've had, then you've got one of the biggest challenges, which is kind of the period of time that we have for the climate emergency. No, sorry, whoops, one more. Well, the climate emergency is a kind of 30-year. So we've got about that long in order to address climate change. And then we've got just the building's life as a whole. So if the building is completed here, we'd expect the building to maybe have a 50-year lifespan or a 100-year lifespan. So our buildings are going to outlast like the life of anyone who have worked on it. And so that's kind of one thing that comes when you start to think about the lifespan of these objects. But there's also, for example, if you completed it as a project here, is that if you use depending on the material, some of those materials may have a different lifespan. So talking about one, you might end up with, something like a plastic, which might have like 1,000-year lifespan for the plastics in your design. And then looking backwards, you might also, for example, have the stone, the concrete, and the iron for that, which might have something like a 350 million year lifespan. But that doesn't have to hold true for all the materials that we use. So for example, for a tree that we use in our design work, it might only have something like 100 years for growth for trees. And then even at the end of its life, some of those materials will have a much shorter lifespan of biodegrading, possibly only about another 100 years or something to biodegrade. So there's lots of different aspects that we can think about when we start thinking about the lifespan of our work and of the materials that we choose, and the kind of architecture that, in some ways, that we're designing for other people's lifespans.
Yeah, just to go back to the last slide, we find that a very promising basis to develop future projects off, because it does, well, we'll come back to that at the end, but we think this is sort of straightforward on superficially. It's quite straightforward thinking like this, but actually, if you play it through, it sort of radically changes what one has to do. Okay, let's go to the next slide. So we have two more little stories. We'll try and speed up. So this was a project that we're not doing, unfortunately, but it was to work with a arts group who had an existing site that they wanted to turn into kind of, or extend their job as a kind of arts compound studios, to extend their public offer. And our view was that they had this existing two-story, single-story sheds, which you can see in the image on the right, these kind of pitched roofs that weren't quite big enough for what they wanted. But we thought a kind of light touch would be not to knock the building down, but to keep it and to place a new lighter roof on top of the pitches to make a single space, and then add buttresses to help stabilize those walls. And what this would mean is that you wouldn't have to build any foundations being quite serious things to do. This was actually a very tight London spot, but also in terms of cost and end use. So the foundations are all above ground effectively. And then within that, you build a warm box as light as possible with the most light touch foundations in itself. And you separate the keeping dry from the keeping warm, but in such a way that allows you to effectively remix what you have in the site in a very sort of, the intention was to be as light touch as possible. Can we carry on?
Yeah.
So then this comes back to something that we've been talking about before. I've been looking at in terms of that we're aware that a large amount of at least in London, and at least for just the first kind of stages of our buildings, that a large amount of the carbon that's in our buildings is actually buried beneath the ground. So we throw a lot of material, we may choose to build tall buildings on very weak soil, and so then we end up having to use 20 to 30%, like the carbon of the whole project would just be in the foundations. And a kind of a better strategy would be to acknowledge where we have weak soil and to build shallower, or if we have strong soil, it would be to build taller. And I think this is something that this needs to kind of become a more normal part of the design process. So most of this, I think the initial response might be that this data is hard to get a hold of, but the British Geological Society hosts their borehole logs on their website. And so for most, at least in London, you're only ever about 20 to 30 meters away from a borehole log for your site. So you could easily identify your site. You could easily identify a borehole log on one side of it, on the other side, and understand your soil, and then be able to plan the intervention, your architecture above ground, and take that into account as part of that process.
And then the last sort of story, this is the only new build, what with almost a quarter of, as Kim was pointing out earlier, that 75 to 80% of buildings that will exist at the end of this 30-year climate adjustment period, 75% will already exist, and only 20-25% will be new. So this is the one that we were including from our set of 4. This is a new build that's just started on site now. It's a housing project called House for Artists for London Borough Barking Dagenham, the Greater London Authority, working with Cradle London. And it creates a series of sort of hyper-adaptable flats which aren't based around corridors and a public ground floor. But the reason to show this one, well, one, there's the materiality which we could discuss, but here we wanted to make sure that there's a kind of adaptability built in, meaning that you have a kind of sparse structure on the inside and a series of soft infill walls, which means that you can quite easily change the building, and it works in layout to even an entirely different function, should it not want to be housing in 50, 60 years. But also, whilst it is housing, it means that you can add and subtract rooms from one apartment to the other. It means that you can add walls without and add compartments without causing a kind of fire issue. And the idea is that the DNA of the building is it's a building that is just material for people to project how they want to live, however they'd like to live. Theo, maybe do you want to say something about it?
No, I think that pretty much covers it. I mean, the key ideas in relationship, what we're discussing today, I think are there. We can potentially discuss in a way of understanding perhaps how lifespan is related to energy, in the way, for example, how we understood light and how at once the kind of what you see here is a gallery space, which is meant to be on every level a kind of shared space, also becomes the shading area, and how the apartments, by being through aspect, allow for light and air to circulate freely, and that reduced quite a lot of the demands of the servicing of these apartments. So it was generally providing the infrastructure, I think, as you said, on every level, and even in the public space, because we also have a public space which we're thinking is very much a kind of space that is going to be integrated and used socially by everybody. So that needs to have its own infrastructure as well. So that's also integrated into the building, into the project, but also into understanding what technology we want to be putting forward together with consultants, and what technology could do for us, I think, both from the structural engineer's point of view and the services point of view.
I think that's a good point. Just to say that we see architecture as a kind of environmental art, and that's historically what it is. It modulates your environment in a particular way, but historically it also responds in such a way that you don't have to use other technological means to keep cool or have to burn to.
I'm sorry, it might worth mentioning also we work with Expeditions and Expedition, the engineers, and also Max Fordham as well, since we are talking about.
Yeah. So should we move on?
So then one of the last things that we had like a kind of abstract conversation about what would a 100-year life building look like. And I think one of the kind of the easiest ones to think about might be, for example, that you think about something like the Pantheon, which has already existed for a long time, and essentially acts through a series of like adaptations over its lifetime. So you have a building that can adapt over time to suit new functions. But I think there's other ways of thinking about that. So that would be, for example, the Pantheon. Just quickly do that as a note. Then you might have something that you have to repair. That you kind of build, perhaps the individual parts of it have a much shorter life, but actually you kind of create a cycle of repair. Something like that might be the Great Mosque of Dejan. I apologize if I pronounced that wrong. Which is a rammed earth structure which annually kind of is repaired and has a kind of timber scaffold that allows for it to be repaired over its lifetime. Then you have kind of the idea of your building or of this architecture lasting 100 years. So an example of that might be something like the Serpentine Pavilion, which no one of those exists for 100 years, but the building, the idea of it exists, and we've seen several buildings on that site to kind of achieve the same kind of function. And then one of the last ones might be actually to have a planned life. So that would be something like the Curtin Valley Park Visitor Center, which is a Building Life project, Building Life Challenge project, which has a planned 150-year lifespan. So the idea that this building and all of its materials not only are good for the environment now, but will last over a particular amount of time. So these are just some ways that you might think to get a building to last 100 years. But then there's another part that comes out of this, is that should you actually be designing buildings that last a long time, last longer than your lifespan, are you forcing your architecture on future generations? And I don't know the answer to that. So that kind of brings us to one of the last slides, which was talking about, we were kind of trying to be slightly, we're just kind of concerned that we might have some younger architects who might want to have might want to have ideas of what they could be doing. And I think one of the key ones that came out of an ACAN event recently was the idea that we kind of need to educate ourselves about all the different parts that make up sustainable building design. So on this wheel, you've got on the outside, you've got the UN sustainability goals, you've got the Living Building Challenge, you have BREEAM, and you have the REBA standards. And one of the interesting things of the IPCC report was saying that if we achieve the UN Sustainable Development Goals, we would be able to, we would be addressing the climate emergency. And so these are all factors that we need to start including in our work. And I guess one of the counter arguments might be that there's not enough time in our work to do that. But when we were talking about this, it was the idea that at the moment we might have only 2 years to design, which leads to a building that has to be adapted or changed after 30 years. And then actually, if we were able to take longer in that design process, if you were doubling that, you may then lead to buildings that last much longer because you've been able to put that time into, that the ratio would stay the same. We would be able to design buildings that last a longer time. So it's just a thought to add when you come back to it. And so, yeah, so to go back to Nick's original kind of reading this.
Nick, go to the next one, sorry.
No.
I guess the reason why we wanted to sort of look at this topic, and we were kind of hoping to see if we can get a discussion going, is that presently when we design buildings, we sort of automatically think about, not us, but in industry, we think about 60 years, 50, 60 years, that's the built-in logic. And the building is a kind of consumable product which has to serve certain ends, but it has its own kind of demise programmed into it. And if you drill down into why 60 years, it comes down to a relationship between capital costs and maintenance costs and all these kind of things. So we can't say that the 60 years is to do with sustainability. We can't say it's to do with architecture. It's to do with a very particular way of seeing the built environment. So our kind of open question, which is what we're kind of thinking about and discussing with, once discussed with Ciaran, is, well, what if we consider why can't an office building be like a tent and last only two years, 2 months? Or why can't a building be seen to never end, and it only kind of dies once it's abandoned? So the uses can keep changing, but it keeps being maintained. And then it's not just a question of engineering, it's a questioning of what are we prepared to spend on our buildings, what are we prepared to kind of remodel how we might build collectively. And just to touch, and I think maybe it's a bit of a surprising reference perhaps, but I was reading recently Christopher Alexander's system of what he views the construction industry as something he calls System B, and he's identified something called System A, which is a completely different conception of the building industry, which would allow for buildings effectively not being seen as 60 years, but being ongoing, and also allow for buildings being seen as only lasting for a few months, but for quite serious uses. And that's kind of for us why lifespan is a kind of fundamental issue that links into all the burning topics we need to be examining now in the next 20 to 30 years.
Yeah, maybe it's worth saying that also looking at this through the lens of a kind of young practice that is establishing a kind of way of working, that it's quite clear, I think, to us, because I suppose at the start you're having to deal with everything from the start, and maybe there's something to be said also about the wider context of where we operate as architects, and it's what Nick just said. It's obviously influenced by the market, capital, the land value, and as we now know as well, taking projects after a few years now on sites, the wider management of realizing projects and the way these things are procured, and so on. So I think the kind of underlying perhaps question as well into the readings of everything that's on the screen right now, you know, from designers' work to theoreticians, historians, and anybody involved in the built environment or has a view in it, is basically how does that operate at a greater scale? So it's not just understanding it in the context of the building itself, but also understanding in the context of the city, and how that operates on the level of infrastructure. I think Ciaran's particularly the slide where he's exploring the connection to the soil and the ground is particularly fertile because of that. Because it's about a kind of moment where we can begin to imagine about things that can be measured in an imaginative way, in a way that is creative, and our relationship to those things can be equally emotional as well as scientific. And I think this is where we are in terms of questions. How do we get to answers? I think we look back and forwards, and we'll see.
Yeah, and maybe we've gone too slowly, but I'd be interested to hear if anyone has any thoughts on it, because we definitely have some questions amongst ourselves to discuss.
Sure. But, we've got a question from James Payne. I can pitch over to you, Nick. You open the question. Yeah. James, can you unmute yourself?
Hi guys, good to see you.
Hi.
Hi.
Been too long.
Yeah.
I've been talking quite a lot about this book, The Architecture of the Well-Tempered Environment, with students, and I suppose my comment leading into a question, hopefully, is I just really think we could do with a critic right now with who had the range of Rainer Banham, who could. It's interesting that his career coincided with the energy crisis of the 70s. In some ways, the same issues, you know, they haven't changed. They were still there. But perhaps at this point, perhaps we could start to reframe the role of the architect and how we teach it, as this link between the visual architectural culture and something which is much more invisible, kind of the invisible thermodynamic performance or embodied carbon of a building, and as complete systems. And it was really interesting to hear you talk, Nick, about how you deal with an old building, and how they need to kind of breathe, really, and they have natural materials, and it goes against everything that you know. So it goes against some of the regulations that we have in this country about air tightness and things like that. I mean, or you know, passive house standards. So just wondering, how do you take this very visual architectural culture and how do you combine it in the way you teach?
Yeah, I think that's exactly what we're sort of struggling with, to be honest, at the moment. But I think there's a couple things. One is that's why I think lifespan is an intriguing topic, because it means that if you radically change what the material being used is, and you change what the energy source coming is into the building, does it get much lighter? Does that mean then you can start to have regulations specific for certain types of building or types of construction, rather than having a sort of generic regulation which doesn't fit having multiple models of what a building is? So that's something we're kind of intrigued by, I think, fair to say. But the other thing, I think questioning passive house is interesting, because every good architect I know, can I say this, hates passive house, it seems. It's not actually true, because obviously the beautiful project in Norwich that won the Sterling, obviously that's a complete embracing, but that's a wonderful thing. But I think even they say at first they were a bit offish, like what on earth is this about? But I think that's a good positive example in the end, because it means that we have to think, in the case of passive house is only one example. It means we have to think very differently from what a modern building looks like, right? A passive house has to look like the early career of modernists, like early career before they start doing huge amounts of glass. So if you think about the summer houses of Alto, those are all passive house in look somehow, right? So I'm just kind of intrigued that we can embrace all these things, be it passive house, but I'm interested in, are there other models that we can embrace passive house, but can we invent other models and invent the regulations to go along with them that allow for more airflow? I don't know, what does Ciaran think? Do you think,
I was thinking about your
where there's leaky buildings, I guess.
No, I was thinking about your building case would be that with that situation, the idea was that you kind of have the really hardcore version of stripping it out and improving it. And so, for example, that might have made sense. For example, if this building was needed for, let's say, 100 or plus years, so it would make sense to completely destroy it and rebuild something new, because over the next 100 years, this building is going to continuously leak out heat, and so it's going to need too much energy. But actually, in some ways, the other argument might be that you've stripped it back, so you actually removed material, which still has a cost. But if you combine that with an environmentally friendly energy source, because you're not re-emitting because of the construction, it could actually, over its lifespan, for the next, I don't know, say 30 years, be okay. So understanding the lifespan of your building can lead to different solutions when given the original kind of same brief. So that was just my thought. That's what I was thinking of while you were discussing.
But sorry.
Could I just go back? I mean, to James's point about this visual side of things. I think both with Ciaran and Nick are exactly within the thinking. I think with Nick we're I think very much in agreement on the topic. I think with Ciaran, which I recently only met as well, but there is, we shouldn't forget that this very moment, because I think there is a real danger here where we sort of feel that this is actually a first and it hasn't been dealt with before as a problem. And I think we shouldn't forget that's not really the case. And you know, these sort of involvement and advancement of technology ever since the whole houses where people would burn woods within the same space they would live, and they were half timbered, all the way to much better and more kind of accepted from the history of architecture good examples like the Sohn House, and you know, there's many people that have written on this extensively about how technology has been assimilated into something that now we look back and we see as possibly a good example of what I think you mean by visual architecture are out there, and I think this should be thought of hand in hand with the next stages of this period of 30 years that Ciaran drew in his diagram, because otherwise you really begin to worry about if those 30 years, if there's so much to be seen and understood in the past 1,000 years about how to deal with this issue, because effectively we're talking about this kind of, as we say in the office, this imaginary man that needs to live within 21 degrees. That's really who we, in everywhere around the world, we're dealing with. And you know, how do we deal with this man? And I think that's also something that shouldn't be forgotten.
Yeah, can I add that? I think it's a good point. I think each country has its own regulations, and that regulation paints a portrait of a virtual person, and that person's quite different in each country. In Japan, it's someone who seems to be more hardy, but in the UK, it seems to be Homer Simpson, like this kind of virtual person who can't look after themselves. But I think that begs the question of where are we looking? And I would like to say one thing about the books on the screen now. These books and their writers, almost all of them, are very problematic in some ways, be it politically, culturally, and so on. I should have said that at the beginning, but that leads on to the idea that actually, if we want to think about buildings in quite a different way, I think actually we have to look outside of the canonical architecture. We have to look outside of the typical particular part of Europe that we're thinking about. And I just think the opportunity to address these issues, which we believe lifespan is a vital one, means that we can break out of sort of culturally repeating the same mistakes again from the past. If that makes any sense.
I mean,
Yeah.
one of the projects kind of from the last decade that I think does address these issues quite explicitly the solid schemes that the Dutch Housing Association Het Oosten has built. You'll know that there's a project that they've undertaken with Tony Fretton in Amsterdam, and I think a couple with Bamschlager Eberle. And in each instance, they're working on the basis of a sort of 200-year lifespan, where the buildings have a structural capacity and are planned in such a way that there's an overabundance of servicing to allow for a variety of uses, not exclusively housing, to take place. And I think you effectively bid in an auction for a certain kind of square meterage of space within the structure, and it might be an apartment, or it might be a dentist's office. Programmatically multivalent, but there's a level of investment in terms of stainless steel reinforcement bars and the concrete structure that's going to allow for this building to last. But all of this is sort of predicated on the fact that the housing association is going to be there in 60, 80 years, and that their return in their investment, the people making the investment now know that the housing association is only going to make the return on that investment after their own lifespans. So there's fundamentally a financial equation that kind of allows them to think in those terms. Yeah, I just wanted to know if you had examples of other positive models like that you.
No, definitely there are. I mean, it's very easy to me to go back to Switzerland. So one of the ways that the quality of building, which means you get very good architects doing now completely zero carbon buildings, which can be considered in capital cost impossible, because you have to pay a lot of what's considered a lot of design fees. You need to pay a lot of for the material itself, is possible because the cooperatives and other organizations, they have a land deal, say 100 years, where they get the land from the state for free. And that takes out a huge lump of the cost. And then they borrow the money to pay for the construction and all the issues around the construction. And that length, 90 years or whatever it is related to the length of the land being free. So once they've paid off the construction, then they start paying into the local coffers again, right? But the people investing, typically their pension funds, they're people who are happy to have 1.5%, 2 and a bit percent returns. They're not happy. I mean, most investors these days, are looking at like 10. Well, a lot of people investing in building quite often are looking at 10+%, and that's what kills it effectively. So that is, again, lifespan is also the financial lifespan. It's it's the kind of
that's a funny way to. That's a funny part. So like when we say that the building has like released carbon, right? We say that it has a particular carbon emission. That's the carbon emission associated with running a process of transporting a particular amount of material. It's about the application of a finish. And so actually there is an argument that actually by reducing the embodied carbon, you're reducing those processes. So actually you should be also reducing the cost. So I think there's a default that actually low carbon means high cost, but I don't think that's necessarily completely true. We don't have enough examples to prove it one way or the other. But like, I think we don't have to assume that it's going to be the worst arrangement.